let's solve this application problem that involves trigonometric functions. A mass hanging from a spring is set in motion, and its ensuing velocity is given by v of t equals 4 pi cosine of pi t for t greater than or equal to 0. Assume that positive direction is upward, then s of 0 equals 0. A. Determine the position function for t greater than or equal to 0. So let's do the solution. Let's work out the solution. So v of t is equal to 4 pi cosine of pi t, where t is greater than or equal to 0. Now s of t is given by integral of v of t dt, because v of t is the derivative of s of t, right? I can write with that dot representing the derivative of s with respect to t. So to find s of t, we integrate both sides. So in this case, it's going to be integral of 4 pi cosine of pi t dt. 4 pi comes in front, and integral of cosine of pi t is sine of pi t over pi plus some constant c. This cancels, and we end up with 4 sine of pi t plus c. They give us initial condition s of 0 equals 0, which means if we plug in t with 0 in here, we are going to get that 4 sine of 0 plus c equals 0. Sine of 0 is 0, so it means c equals 0. So in other words, s of t, the position function, is equal to 4 sine of pi t for t greater than or equal to 0. So we determine the position function. This is the position function. Part B, graph the position function on the interval 0, 3, including 0 and 3. So let's graph that. We want to graph the s of t that we have here on 0 and 3. So in order to do that, we want to graph 4 sine of pi t, which means the amplitude is 4. So when I go here, 1, 2, 3, 4, and 1, 2, 3, 4. Maybe I shouldn't put a closed dot there, just a 4. So the amplitude is 4. The period, well, the period is 2 pi, which is the period of sine of t, divided by whatever number we have in front of t, by pi. So the period is 2. What does that mean? It means that the function sine of pi t repeats every 2. So from 2, 4, 6, and so on, it repeats. The same way sine of t repeats every 2 pi. Now the scale is given by the period divided by 4. So in this case, it's 2 over 4, or a half. So basically, we have 0, 1 over 2, 1, 3 over 2, 2, and so on. These values are producing the same values. These values are producing for sine of pi t the same values that 0, pi over 2, pi, 3 pi over 2, 2 pi produce for just sine of t. So how do we graph that? Well, let's put the scale. So 1 over 2, 1, 3 over 2, 2, 5 over 2, 6 over 2, which is 3, 7 over 2, 8 over 2, which is 4. And so basically, let's see, did they want us to graph it? They wanted to graph it only on 0, 3. So let's keep that in mind. So now, the function sine starts at 0 and then goes up to 4. At 1 is 0, at 3 over 2 is negative 4. And so we just go like this. And I'm going to stop at 3 just because the function was asking for the graph on 0, 3. Now, in part C, it says at what times, right, this is the time, does the mass reach its lowest point the first 3 times. So the first time its lowest point, it's attained at t equals 3 over 2. That's the first time. Now, this graph, it's just up to 3. So if I were to expand it, we would go like this, right? And then at 9 over 2, we'll go all the way here, right? So the next time it's a minimum, it's 3 over 2 plus the period, which is 2. So it's actually at 7 over 2, which is represented by the graph as well. So at 7 over 2, and then we want one more time, so 7 over 2 plus the period, it's 11 over 2, so that would be the next point. Now, just because in part C, it didn't restrict us to the interval 0, 3. We had to use the whole condition where t was greater than or equal to 0. D, at what times does the mass reach its highest point? The first 3 times. So the first time it reaches its highest point, it's t equals a half. Then we also reach the highest point at 5 over 2 just by looking at the graph, but we can also say 1 over 2 plus the period 2, which gives us 5 over 2, and then 5 over 2 plus one more period, which gives us 9 over 2. And we can actually see that from the graph as well. I hope this helps.